Well, in our first discussion, we talked about light and color and how color is actually a perception. It doesn't really exist, and that's sometimes difficult for people to get their heads around at first. But color is a result of light reflecting off a surface or the result of direct light, and that light hits our retina and stimulates electronic impulses down our optic nerve into our brains, and we see color. And we also talked about the different types of light, direct and indirect, source of origin, types of direct light, whether it's incandescent or whether it's luminescent, and the various light qualities. We talked about pigment, which is a substance that reflects and absorbs light waves, and any surface that has color in it has pigment. Surfaces that don't are called transparent. They transmit light only, they do not reflect and absorb. And then the combination of the two would be translucent surfaces, which reflect and absorb as well as transmit light. We also talked about surface quality. We talked about rough surfaces causing light waves to reflect in a scattering, kind of a random pattern, and light waves are diffused as they come off the surface, and so color does not look as brilliant. But on a smoother surface, something that's really highly polished, the color looks really intense comparatively, because the light waves are all coming off at the same angle, and that will compound the sense of brilliance. And then we talked about color systems and how color is best understood in a system. There's a lot of creative aspects in color, but there's also a very systematic, scientific, logical order to it. We talked about color systems being two, one being additive, one being subtractive, and the additive deals with the realm of direct light. And then the subtractive system is reflected light, or the area of pigment, and so that's what we're talking about in this lecture. So just to review, both systems will have hues, which are color families. We need to understand that the subtractive system, the reflected light pigment system, is derived, or it originates out of the additive. You can't have the subtractive until you have the additive. So if you turn out all the lights, you don't see anything. The primary hues in additive color are red, green, and blue, and they combine to create all the other colors within the additive spectrum. And if you combine all three together at equal amounts, you will get white light. The additive and subtractive systems are related in this way. The additive secondaries, when you mix the two primaries together to create the secondary, those secondaries are technically or scientifically the subtractive primaries. So magenta, cyan, and yellow are understood as red, blue, and yellow, which are the traditional primaries. The red, yellow, blue system is pigment oriented. It deals with reflected light. And we have the traditional red, yellow, blue system, which is more of a crimson red, an ultramarine blue, and a yellow. And we also have the technical or scientific understanding of that, which is actually the most correct, which is the magenta, which is part of the red family, the cyan, which is part of the blue family. So magenta is a red, and cyan is a blue, and then we have the yellow. These three hues become the primaries in the subtractive system. So this slide just basically shows what I already talked about, the traditional understanding of red, yellow, and blue, and the scientific or technical understanding of red, yellow, and blue. So understand that these are basically the same things stated different ways. This is still subtractive. This is representing the same system as our traditional understanding. Remember that a primary is a hue that cannot be made or created by mixing any other hues together. So primaries are foundational hues. When you mix two primaries together, you create secondary hues. Again, they're hues. They are color families. They are spectral level hue family representatives. So now we have the red, yellow, and blue. If we mix red and yellow, we will get orange, and if we mix red and blue, we will get violet. So orange, green, and violet are secondaries. Secondaries are created by mixing two primaries together. And as you'll find out when working with the gouache, you'll understand that it's a perceptual mixture. It is not a volume or amount mixture. If you mix 50% red and 50% yellow to make 100% of your volume, you're not going to get orange. You're actually going to get a warm red because of the different wavelength character of the hue itself. So what we're looking for when we do subtractive color mixing is a visual or perceptual mixture that sits halfway between the two primaries. So orange is neither too yellow nor too red. When you mix a primary with a secondary, you get a tertiary, and that's the third understanding of hue. It is not a level. In other words, primaries are hierarchical only in that they're foundational and they're known as simple hues. There are 3 primaries, 3 secondaries, 6 tertiaries. Tertiaries are understood easily because they are compound names as well as compound hues, so you'll see the hyphens. Technically, it's correct to say the name of the primary first. So it's not orange-red, it's red-orange. It's not orange-yellow, it's yellow-orange. And red-orange is distinct from yellow-orange, and both red-orange and yellow-orange are distinct from orange. So we don't have oranges. We have orange, yellow-orange, and red-orange. There is a natural order known as spectral sequence. If you place the 3 primaries in the hue circle equidistant from each other, the influence of each primary covers 2/3 of the hue circle. The influence of each primary is greatest when it's sitting there alone. So at the position where red is on the hue circle, red is the most influential. It's at its greatest amount. As red moves toward yellow, or it moves the other direction toward blue, it starts fading away. And so we have, in terms of the 3 primaries, kind of a cross-section, an idea of peaks in terms of amount. So here you have your greatest amount of blue, your greatest amount of red, and your greatest amount of yellow. And as yellow moves toward red, we start seeing the influence of red and the decreasing influence of yellow. Halfway between, we get to orange, and then as we move over, we get into red-orange, and then into red, and then we're into red-violet as blue starts having an influence, and then violet, which sits right between red and blue, and then as we move toward blue further, we have blue-violet. So each of the primaries influences 2/3 of the circle in varying amounts, and that is how we have a natural order, or what's known as a spectral sequence. In reality, there is no distinct boundaries between hues. They fade into each other. And at the point where yellow becomes influenced enough by blue to become yellow-green exists. The proper understanding of a hue circle is more like this than how this is depicted with the separate compartments, but this makes it easier to understand the concepts. This is what you're going to be working with more in terms of digital color, where the spectrum is laid out in a continuing flow. This also reflects what's going on in the subtractive circle. The idea of subtraction, of course, is that light is subtracted away. The pigments are absorbing light and removing light from the mix. When you have a combination of all 3 primaries in the subtractive, you get this resulting black, and black absorbs all the light waves in the spectrum. The black that we actually get by mixing red, yellow, blue, or cyan, magenta, and yellow is actually a really dark gray, and it's not black, but it's really dark. It's darker than a battleship gray. And because it's not pure black, that's why we have in 4-color process printing, we have to add black, which makes it 4-color rather than 3-color. In subtractive color, there is no pure black. Pure black happens only when you take away all the light. You can always take a black surface, cast a shadow on it, and make it blacker. You do not have pure black in subtractive understanding. The only time that you would experience pure black is if there is absolutely no light, which doesn't happen a lot, especially if we live in an urban environment. If you reduce the color to the 3 primaries to, say, a 50% screen and mix them together, you're going to get about a 50% gray. Subtraction still happens, but when we have more light reflected off the surface, the black will lighten up into grays. White, which you see here all around, is a ground color, is in subtractive considered lack of chroma, lack of color. White itself is a color, but it's not a chromatic color. Black itself is a color, but it's not chromatic. And the various shades of gray are also colors, but they're not chromatic. So there's a school of thought that separates black, white, and gray from colors. But since we use them as colors and they have pigment in the subtractive, they are actually colors, but they're achromatic. The subtractive system also has three properties. In this case, the properties are hue, value, and intensity. If you remember the additive system, we had hue, luminance, and saturation. Hue is the same in each. It's the perception of chroma, or the name of a color family. Value in the subtractive system is the perception of lightness and darkness of a color. Yellow is always going to be lighter than red at spectral level. And pink is a tint of red, so pink will always be lighter than what we understand to be pure red. Intensity is the purity of a color, and we'll talk in lecture 3 a little more about intensity, but it's a perception of the brightness or dullness of a color. So you can have a light bright or a dark bright color. You can have a light dull or a dark dull color. There is a bit of relationship, especially with value, to the additive properties of hue, luminance, and saturation. One more thing to understand about color is that it does exist in a spatial understanding. A color circle, a hue circle or color wheel, is a two-dimensional systematic arrangement of color. Color exists in 3 dimensions. We have various factors or various criteria by which we pinpoint color within a space. If you're used to working with Photoshop and you have played around with the modes, you'll understand that there's a grayscale mode, there's a bitmap mode, there's a CMYK mode, there's an RGB mode, and all of those modes are color spaces. The hue circle is a flattened version of the subtractive color sphere. These are kind of wireframe models of a subtractive sphere. We're seeing the red into the violet, into the blue, into the green, into the yellow, and orange is back on this side. We see the orange on this side. But we see the lighter colors at the top and the darker colors at the bottom. So there's a polarity. The lighter colors exist at the top of the sphere and the darker ones exist at the bottom. Down the center core, we'd have white at the top and then we would have black at the bottom. And so the center core would be all the gray possibilities. One more thing about color is understanding that what we see reflected from a surface we do not see in a vacuum. So say like right now I've got a blue coffee mug on my desk, and then my desk is kind of a lighter ash color, it's wood. And so the coffee mug, the blueness of it is affected by the surrounding color of the wood. Or if you hold your hand up in front of you, you've got your flesh tone, but then you're also seeing that against whatever the background is. We never see any color in total isolation. Because of that, a color has an action on itself. And one of the things that we do need to understand is the after image. And the after image is what makes the Itten 12 hue system the most practical of all the subtractive systems. The Itten 12 hue system is the one that's just been described. There are other systems of color. There's Goethe, there's Holzhol, there's Munsell, there's Ostwald. There's a variety of systems that are discussed in your textbook. The Itten is the most practical because it is the one that closely seems to reflect actuality. It reflects reality. So it is trustworthy. Itten was a teacher at the Bauhaus School and a crony of Joseph Albers, and was a color theorist and teacher, and devising the systematic arrangement of color into the 12 hues with the 3 primaries, the 3 secondaries, the 3 tertiaries, and the arrangement of color in that system due to the after image, which is a visual phenomenon. It's a visual effect. To understand what the after image is, we're going to experience it. What I'd like you to do is look at the black circle for several seconds. And what you should be seeing is in the upper left, it's sort of green. In the upper right, it's sort of violet in color. In the lower left, it's sort of orangey. And in the lower right, it should be kind of pink. You've just experienced the after image. And that is a perceptual phenomenon that happens because of how your visual system works. In your retina, you have rods and cones. Your cone cells measure the wavelengths that come in. And you have cone cells that fire off of 3 different sets of wavelengths, red, green, and blue. And so if you're looking at something that's red, the red receptors are going to be fatigued, much as if you're going to the gym, you work out, and start fatiguing your muscles with the effort. And it takes some time for the muscles to kind of come back into full capability. The same thing happens here in your eye, so that if you're getting a lot of red stimulation, those cells that are receiving the red are going to fatigue, and the result is that you will see the opposite of red, which is green, which happens to be a combination of yellow and blue, the other 2 primaries. Understanding this, if you're looking at this and then you transfer your eye over here, you're going to see green as a after image on the gray. And if you're looking at the yellow, you're going to see a little bit of violet as an after image on the gray. The reason this is on gray, first of all, gray is, this particular gray has no after image because it has no chroma. And it is halfway between white and black, so you can't see it any lighter than it is, and you can't see it any darker than it is. So after image doesn't happen with a mid-value gray, kind of a middle gray. The after image of black is white, the after image of white is black. No matter what color we're looking at, unless it's gray, all colors have an after image, and those after images will be imposed on the colors that are around them, affecting how we see color.